Hello and good evening, CTS266 Section 840 students for the spring 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this tutorial is going to be a supplement to your EtherChannel studies, which we have coming up here for week number 3. So here's what we're going to cover in this tutorial. We're going to talk about the spanning tree port cost and how that gets adjusted as we add links into the EtherChannel. We're going to talk about the LACP System Priority and the LACP Port Priority. And we're also going to take a look at load balancing. Okay, so let's go ahead and dive in here. Actually, what we want to do is let's pull up the screen. Now, full disclosure, I actually just spent an hour and 15 minutes recording this exact video, only to have my hard drive fill up and I lost the entire recording. So that's why all of this is already written up here on the screen. So I'll switch to blue for take 2, if you will, or the bonus lab. And so actually you can already see with the different links over here, and I'll add the links in a couple at a time. The key point is when we have fast Ethernet interfaces, which is what we're dealing with here, you'll notice that when we have 8 of them in the EtherChannel bundle, the spanning tree port cost is 5. So why is it 5? Why did it go from 5 to 5? Why didn't it go from 5 to 4? Well, the reason is because when we have 800 meg links in the bundle, we have an 800 megabit per second bandwidth. However, the cost of the 1 gigabit per second link for spanning tree is 4. So it doesn't make sense to drop this from 5 to 4 here, because we don't want those to be equal cost, because again, this link here is faster than these 8 bundled links that are all bundled up together. All right, so here's how we're set up. We have a host over here, and we have a host over here. We've got 16 links, so let's get started. Let's dive in here on the command line, and if I were to say, go into privilege exec and say show interfaces trunk, what do we have? Well, we have one port channel, it looks like, that we've already configured. Let me say show spanning tree, and I believe, yeah, so we've got those 2 interfaces there. So what about a show EtherChannel summary here? And again, I apologize, I had already completed this lab. All right, so we've got 4 links in there. So when I say show spanning tree, with 4 links, our cost is 8. So let's go ahead and add in, let's go into global config. Let me say do show run, and let's begin at FA1035. And what we would expect to see, not FA, we'll do that there. All right, so these are already 35, 36. So from 37 down, we're shut down. So let's go ahead, we'll add 2 links in. So interface range, FA1037, FA1037 to 38, and we'll say no shut. So let's pull those links into the EtherChannel here. Excuse me, you see the links will come up. I've got a debug LACP events on, so it's going to show us a little additional information as well. We can see how the links are pulled into a standby status. They transition from standby to selected, and then let's say do show EtherChannel summary, and now we have 37 and 38 have been added in, so we've got a total of 6 links. Now what does our spanning tree cost? Do show spanning tree. So again, we confirm it drops to 6. Let's add those last 2 links in. Interface range FA1039 to 40, and we'll say no shut. And so let's say show EtherChannel summary. And there we go. It's going from standby, or goes into standby mode. It gets set to standby, and then they transition into selected, which is where they will now show up as being bundled in with the rest of the links. So now 8 is the maximum number of links we can have in an LACP EtherChannel bundle that are active at the same time. So maximum of 8 links active at the same time. Let's go into global config to bring everything else up. So interface range FA1041 to 48, and we're going to go ahead and say no shut. And then we'll type end, and we're going to go ahead and say, what are we doing here? Let's let this finish up. So these are the debugs that are going to go back and forth here. All right, there we go. So let's go ahead and say Show EtherChannel Summary. And all of these remaining 8 links, right? See those 8 links right there from 41 to 48? These are all going to be placed into the hot standby state. So we have our 8 primary, if you will, or active LACP ports that are in the EtherChannel. And then we have these 8 hot standbys. So if for whatever reason, if I were to go into global config and go into interface FA, let's just pick 1037, right? So FA1037, and I'm going to say shut. Let's see which link is the switch going to pick to replace FA1037. So do show EtherChannel Summary. And we've got, where did it go? So that was the downed interface, and then 41, which is the first interface comes up. Now here's why it picks 41. Because of the hot standby ports, it's the port with the lowest port number. Because when I say do show EtherChannel, is it detail? I don't believe it's detail. No, do show LACP neighbor. Yeah, do show LACP neighbor. So when I do the do show LACP neighbor, you can see here that all of the port priorities are the same. So therefore, the tiebreaker here is that it's going to grab the port with the lowest port number out of the hot standbys. So let's bring that interface back up. So we're going to say no shut. We're going to bring 37 back up. And so now we're kind of going to transition here into, if I say do show spanning tree, you can see the cost is 5. We have 8 links and the cost is 5. So do show span, and there's our cost of 5. All right, so now here's what we're going to do. Let's say do show LACP neighbor. So let's say that if any of the 8 primary links were to fail, 33 through 40, that for whatever reason I want FA1045 to be the link that takes over first. Well, all I would have to do is go into interface FA1045 and say LACP Port Priority. Now we see it defaults to 32768 with LACP Port Priority and System Priority. The lower the priority is, the more attractive or preferable the port is going to be. So if I were to set this to 1000, right? So we'll say LACP Port Priority 1000. And now let's go back into interface 1037. So I'm going to do a do show EtherChannel Summary. Let's see, where do we stand right now? Well, all 8 of the primary ports are up, 33 through 40. And then 41 to 48 are all in standby mode. But we've said for FA1045, we set the LACP port priority to 1000, which is well below 32768. And so this is what the LACP port priority is all about. It's going to dictate which ports that are sitting there in the hot standby mode are going to be selected first. So let's go ahead and say shut. We're going to take down FA1037. Now you'll notice, I thought this was interesting. You can see it says it selected FA1041, which I thought was interesting. You can see here, Fast Ethernet 1041 is up. But let's take a look. Do show EtherChannel Summary. It picked 41. Well, why is that? Why do you think, even though we set the port priority on 45 to a lower value, how come 41 is being selected? And so this is a great segue, and again, that was intentional because this is a great segue into the second LACP setting, which is the system priority. So by default, the system priority is also 32768. However, when there is a tie in system priority, similar to the bridge ID, we go to MAC address. So we were on DLSW01. his MAC is 001 Delta A27. If we look over here, the MAC is 001 Delta A26. So, when we talk about LACP system priority, it's all about who is making the decisions as to which ports are going to be brought online. So there is a master switch here when we're talking about LACP that is going to dictate which ports will be used or brought up when we have a failure, or, and we're going to see this here in a second, when I set the LACP priority on all of the hot standbys to something lower than 32.768. But for the use case right now, the problem is that distribution layer switch 2 dictates which port takes over when a port fails. So let's vet that out. Let's make sure that that's the case. So let's go to DLSW2. And let's go from user exec to privilege exec into global config. And we are going to say do show EtherChannel Summary. Oops, sorry. Do show EtherChannel Summary. All right, so 41 is up. We just took 37 down. So let's do this. Remember, DLSW2 is dictating which port, because it has the lower MAC address in the competition for the LACP system priority. So let's do this. Let's prove that. I'm going to go ahead and go into interface FA6047. And I'm going to say LACP Port Priority. Let's set it to 500. Right? So we just set the port priority to 500 on port 47. I'm then going to go into FA6034, which is active and in the bundle right now, and I'm simply going to say shut. Now, remember before, over on distribution layer 1, what did we see? We saw 41 get selected. Now, take a look at what happens here. It initially tells us 42 is moved into the up state. But then LACP is negotiating. It is a protocol that is constantly negotiating the LACP settings between these two LACP neighbors. So it takes 42 down when it realizes, no, the priority on 6047, the LACP port priority, is lower. That is going to be the switch, or I'm sorry, the port on this switch that gets selected. And remember, we set the LACP port priority, do show run interface FA6047. We set it to 500, which is lower than 32.768. So what happens is the second port to fail, right, because we already had failed one over and the default was 32.768. Now it's 47. So let me ask you this. What's going to happen if I go into interface FA60, or let's do interface range FA6034, comma FA6037, and I say no shut. So we're going to restore, and I actually think I'm going to have to do that over here. Interface FA1034, no shut. And let's make sure we restore the, let's get 37 there. All right, so do show EtherChannel Summary. So let's restore the original state. And let's see what happens. Now remember, the LACP port priority has been set on the other side. So take a look at what happens. We get 1, 2, 3, 4, 5, 6, 7, and then it doesn't choose 40. It chooses 47 because, again, distribution layer switch 2 has a lower LACP system priority. So he is going to dictate the 8 ports out of these 16 that get added in. Now, let's see if it'll pick a change up on the fly. Let me go into interface FA6048 and say LACP port priority 500. Because that's lower than 7 of the currently active ports. And let's see what happens. Take a look. So 1039 gets pushed into the unselected state. So the distribution layer switch 1 now has 33, 34, 35, 36, 37, 38, 47, and 48. So why did it offline 41st and then 39? Because I'll bet you the next time we do that, 38 goes next. Because remember, on DLSW1, if all things are equal, the tiebreaker with the ports is the lowest port number. So over on distribution layer switch 2, we tweak the port priority, the LACP port priority on 47 and 48. So it's going to offline the highest numbered switch ports that remain, right? And so that's exactly what we see happen. Okay? All right. So the next thing we're going to do is we're going to turn things upside down here. So watch what happens. Remember I said for the LACP System Priority, LACP System Priority, the value can be anything from 0 to 65535. Just like the port priority, the default is 32768. Now, LACP is constantly negotiating back and forth and checking to make sure that the settings are correct, and if they're not, it's making the adjustments so that we have redundancy and fault tolerance with these additional links between the switches. So, what happens if I say LACP System Priority 100? Because now what we're doing is we're telling these two switches that it's going to be DLSW01 who will dictate which ports come online and which ports are offline. So remember what we've got up here. We've got 33 to 38 and then 47 and 48. But remember, 47 and 48 had their port priorities changed over on DLS02 when he was in charge. And when I hit enter right here, DLS distribution layer switch 2 is no longer in charge. Because now the decision as to which ports in the Ether channel are going to be brought online, that is going to be made by distribution layer switch 1. So now distribution layer switch 1 will take a look at his ports and see, are all the port priorities the same, 32768? If they are, then I'm simply going to pick the first 8 lowest port numbers to stick into that port channel. Now, if I say do show LACP neighbor, did we tweak one of these? We tweaked 2 of these guys. So we tweaked 47 and 48. All right, so we should see, and actually, let me do this. Let's go interface FA1044. That's going to be a hot standby. We're going to say LACP port. I want it to look different than it did before with when switch 2 was in charge. So we'll say LACP port priority 500. And we're going to see some debugs here because, again, we just changed the port priority. So here it goes, right? So let's go ahead and say do show EtherChannel Summary. And actually, let's let this finish up here. Debugs are going crazy. All right, so there we go. So do show EtherChannel Summary. So what do we have? We've got 33, 34, 35, 36, 37, 38. And actually, we're still kind of in a waiting state there. We've got 39 in a waiting state. But take a look at 44. So 44 was bundled into the channel. And let's see what else we've got. And I have a sneaking suspicion. Do show IP interface brief. Let's make sure that these interfaces are all up. Make sure I didn't leave anybody shut down here. All right. So we've got up, down. So 39... to 43. Did I set do show IP interface brief? Let's make sure that I don't have anybody administratively down over here. All right, so we're good. So over on DLSW01, when I say do show EtherChannel Summary, we pick the, and actually this is not true. So let me see something here real quick. Do show LACP neighbor. Because what we would expect is we should see 47 and 48. And 44 did not pick up the change. So did I? Let me make sure I didn't set the do show LACP sys-ID. Yeah, so it is 32768 over here. And let's check over here and see what we are. Do show LACP system ID, and it's 100. So this switch should be in charge of who is being selected. So it should be 4748. And let's go ahead and say do show run interface FA 6047 and 6048. Let's pull those out. All right, so interface range FA 6047 to 48. No LACP port priority. And oops, sorry. Let's take a look here and see what we see. And I guess we're going to have to say port priority 500. Let's do that. And it is not letting me drop those out. I'm wondering if I may have caused things to hang up. So let's do this. I'm going to do interface range FA 6033 to 48. And we're going to shut, not 38, I wanted 48, hold on, 48. And we're going to shut all of the ports down. And again, I've been making multiple changes back and forth here in a previous recording that crashed. And so then let's say no shut. So we shut everything down. Let's bring everything back up. Let's step back over here to distribution layer switch 1, who should be the LACP master in this case, or the primary. We've got a lower system priority, and we have two ports, 47 and 48, that have the port priority set to 500, which is well below 32768, which is the default. So what we should expect to see here, let's see where we stand right now. Yeah, so we've got lots of standbys. So it looks like it picked up 44 and 45. And the reason for that, I guess, you know what? So I didn't see 45 getting picked up, but it was holding on to 47 and 48. So when I say do show LACP neighbor, yeah, and I'm wondering if making all these changes has kind of tweaked things. So let's get an interface FA 1048, and we're going to say no LACP port priority 500. Do show run interface FA 1048. All right, so that's gone. Do show EtherChannel Summary. And let me do the same thing here for interface range FA 1033 to 48. Shut. So we're going to shut all these ports down. I'm going to bring them back up in the hopes that it clears things up. Because again, distribution layer switch 1 should be doing all of the negotiation and dictating the ports based off the port priority settings that are being selected to actively participate in the EtherChannel bundle. And so we'll go ahead and let this finish up here. Do show EtherChannel Summary. We'll see where we're at. All right, so everything is back to the default settings. So all the port priorities are 32768 on both sides. All the interfaces have been shut down, and then all the interfaces have been brought back up. And it looks like it still prefers 44 and 45. Do show run int FA 6044. Oh, sorry, 1044. And this is interesting where that priority command is still sitting in there. So let's go into interface, FA, and this is why it's choosing 1044. So this is kind of good, right? A little fortuitous failure here. So no LACP port priority 500. And interface FA 1045, no, and the same thing. Do show run in FA 1045 and 1044. All right, so now we should be back here. And I apologize, those commands should not have been in there. So do show LACP neighbor. So it's funny, is 48 do show run in FA 1048. So it's funny, it's showing 48 as having that set. So this could be, again, where it's kind of hanging up because I've been making like an insane amount of changes with this throughout the day today. All right, so let's take a look here. Do show EtherChannel Summary. Where do we stand? All right, we are back to our original config. These 8 ports are the primary ports. And excuse me. And then we've got these 8 hot standby. So again, DLSW01 should be dictating. If I were to go into interface FA 1043 and say LACP port priority 5, then this port here should supplant FA 1040. Excuse me. But it could be hung up. Show LACP neighbor. Yeah, do show run int FA 1043. And it took it. Okay, there we go. And it should take 40 offline. All right, just took it a few seconds there. I was getting a little nervous. We've been having some, like I said, it's been kind of funky here. So do show EtherChannel Summary. And it is distribution 1 that dictates the ports that are going to be active. To prove it, if I come back over here to distribution layer 2 and say interface FA 1040, let's say 46, interface FA, sorry, 6046, and I say LACP port priority of 5, is this going to change anything? Do show run interface, or I'm sorry, not do show run interface, do show EtherChannel Summary. Did it all of a sudden pick up port, and do we use 46? Yeah, we use 46. It didn't, because who has the lower LACP system priority right now? It's distribution layer switch 1. So the only thing that command has done when I said LACP port priority 5 is on distribution layer switch 2, right? If it were to be in charge, it would have changed things and brought that port online and then offlined the next highest number port with the default port priority, which would have been 6039. All right, so that covers the system priority as well as the port priority. The last thing we're going to look at, and I actually spoke to a friend of mine in one of the Cisco business units for the Catalyst switches, and I've got some clarification on that show EtherChannel 1 port channel command and why we're seeing the load as all zeros, right? Or the index, sorry. Why the index is showing up as all zeros. And it was interesting when he explained it to me. It made great sense because that's why Lab 3.2 doesn't have us run that command. So in the command I'm talking about here is show EtherChannel 1 port channel. Now this is a great command, and take a look here. It gives us all of the ports that are in the port channel. And this was bothering me earlier today when we ran upon this. We were doing the packets and checking the packets and using the test command, and that was fine. However, on 6500 series switches and on 4500 series switches, you end up with the ports indexed, and it shows you a value in hexadecimal for the load, and you get a bit count. The reason that you don't see that, and the reason that all of these values are 0 and will remain 0, is because the 3750 and the 3560s, 2960s, those are lower end switches. So on those switches, you're going to use the test EtherChannel command. You're not going to use this command here. But on the higher end switches, where all of those statistics are going to be maintained, you will see that on the higher end switches. So it just has to do with the fact that the 3750s I'm using, and then in the labs, those 3560 V2s and the 2960s, those are lower end switches which are not going to track all of these statistics here. Higher end switches, 6500, 4500, 6800, you're going to see that information. All right, so we're going to use the Show Port Channel, oh, not Port Security, sorry, Show EtherChannel LoadBalance. So we're doing source and destination IP right now. So if we go back to the drawing, what do we have here? So the source and destination IPs, whoops, I want to move that actually. Source and destination IPs are going to be 10.1.1.10 and 10.1.1.11. Now remember, I'm using 8 links in the EtherChannel, which means the last 3 bits are going to be exclusive ORed. Because remember, I've got 8 links. I have to look at the last 3 bits to get the 8 different possibilities. And so what will that look like? Let me change the color here to, actually let's go with red. So that's going to be red. So when we go to set this up, we're looking at the last 8 bits. So if the last octet of the IP of the black MacBook is 10 and the white MacBook is 11, in binary, 10 would be 48010. However, we're only interested in the last 3 bits of each of these. And so then 11 would be 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 4, and then 8, 10, 11. So here's what we have for the last 3 bits when we're using an EtherChannel that has 8 links. Again, due to the fact that it has 8 links, we can't just look at 1 bit because that only gives us 2 options, like we saw with the 2-link EtherChannel, right? So with the 8, we have to do an exclusive OR here of each of these to get the value. So 0 and 0 would be 0. 1 and 1 is 0. And 0 and 1 is 1. So the link with the index 001 is the link over which the traffic should travel. Now, I would think that 000 would be the top, or I shouldn't say the top. The first link should be the first link in the EtherChannel, right? And then 001 would be the second link. So let's check that out. So again, we simply do an exclusive OR against the last 3 bits. That gives me the hash or the index. And again, we can't see the index for the 8 ports on the 3750, unfortunately, but we've got the test EtherChannel command that's going to tell us how this would work because we're doing source and destination IP on both sides. So let me squeegee the screen here, and let's bust out that test EtherChannel command. So on DLSW02, if I were to say test EtherChannel load balance interface port channel 1, I'm going to say IP address, and we'll put down the source IP, which would be, let's say, 10.1.1.11, and then the destination IP address is going to be 10.1.1.10. So again, going from the white MacBook through distribution layer switch 2 over to the black MacBook. And it would select FA6035. So let's take a look. If I were to say show EtherChannel 1 port channel, when we look at that, there is the link right there. but it doesn't give us an index, right? We don't see the index, but we know that that is the link that it would go over. So let's make sure that this is functioning properly. And the easiest way for me to do that, and I'm pulling, you can't see what I'm doing right now, but I'm pulling up the system preferences here on the black MacBook, and we're going to change the black MacBook address so that it hashes to something different. So let's do this. What are we going to do here? So the white MacBook is .11, and we know that .11 is going to be 1, 2, 3, 4, and then what do we have here? 8, 9, 10, 11. So, but again, we only want those last 3 bits. So if I'm doing exclusive ORs here, I'm going to force it so that it's all zeros. So I would want to have a 0, a 1, and a 1. But let's do this. I'll do 1 and 1 here, right? So we'll make the values, what do we have? 128, 64, 32, so 16, 24, 25, 26, 27. So I'm going to change the IP to .27 on the black MacBook. And then, and actually I really don't have to change it because we can't look at this output here, so me pumping traffic through is not going to make sense. So let's change the IPs in the test command to 11 and 27, and that will exclusive OR to 0, 0, 0. And if I had to guess, it should hash to something other than 6035. And if I had to guess, I would say 6033, because again, we've got all zeros here. So I would think it would jump the first port in the bundle. So let's check that out here. So let's squeegee the screen. Let's pull that test command back up. And the destination will be 27. All right, so it definitely hashed out to something different. Not what we expected, right? But that's okay. So, because here's what you can start to put together, is that 37 would be 0, 0, 0 from the exclusive OR in an 8-link Ether channel. When we use the original IPs, 10 and 11, not 27, but 10 and 11, I think it hashed out to 35. So far, we've seen what happens with 001 and 000. So 000 went to 37. 001, when it did the hash on the source destination IP, went to 35. So how would we get 111? So I'm curious about that, right? So for it to be 111, none of the bits, for the hash to result in a 111, the last 3 bits can't match. So what would that look like? And again, you can sit and you can play with this to figure out what would happen. So if I put, let's do 111 for the white MacBook, or for the source, we'll say the source MacBook. And so this would equal, what is that, 6? So 1, 2, 3, 4, 1, 2, 3, 4. So 4, 2, and 1, I'm sorry, 7. And then that's our source. And then the destination, we want it to be 0, 0, 0 here. So I'm going to make the destination, I'll just put a 1 there because the IP can't be 0. At least with the /24s we're working with here. So if I put the 1 here, then that would be 8. So .7 for the white MacBook, or the source, .8 for the destination. In fact, let's leave that up there. Let's rerun that test command, and let's change these IPs to 7 and 8. And that hashes to 38. So when it's all ones, as a result of the hash between the source IP, and again, there's where we got the all ones, right? 0 and 1 is 1, 0 and 1 is 1, 0 and 1 is 1. So when it hashed to all ones, it goes to port 38. So again, there's 8 different values that you can have, right? Total. And I won't do them all. So 000, or like demonstrate all of them. 001, 010, 011, and then we've got, I think that's it for that, 100, and we'll come down here and complete 101, 111. So 1, 2, 3, 4, 5, 6, 7. I'm missing. Well, there's always one I'm missing here. 110. I don't have that. 110. There we go. 1, 2, 3, 4, 5, 6, 7, 8. All right, so there are 5 of the 8. There are the remaining 3. So you could easily figure out, right, on the 3750 using, or 3560 or 2960, using this test EtherChannel load balance command right here by simply rigging the values for each result, each of the 8 results, to come up with what the index would be, right? And again, we don't see this information because it's a lower end switch and it's not going to track all of that for us. All right, so that's using source and destination IP. The other XOR scenario that we get into is when we have the MAC addresses, source and destination MAC, and that's where you have to do an XOR as well. And again, you're XORing the last 3 bits, and that is predicated on the number of possibilities, or I should say the number of links in the ether channel. Because 2 to the 3 is equal to 8, right? So for 8 links or 7 links or 6 links or 5 links for that matter, if this ether channel has 8, 7, 6, or 5 links in it, we will compare the last 3 bits. Because remember, 2 to the 2 equals 4. So that's going to that'll cover 4 bits or 3 bits. I'm sorry, not 4 links or 3 links, right? And we would do an X exclusive XOR against the last 2. So to wrap things up here, let's do that. I'm going to shut down 4 links. And again, this is some good stuff, right? It's good to know how your traffic is going to hash going across these links. So here's what we're going to do. I'm back in the command line here, and I'm losing my place. So let's go into global config, and I'm going to say interface range FA60, 1, 2, 3. So the last 4 links are what? And actually, let me shut these down over on DLS1. And we'll actually run our test from over here on DLS1. So let's go ahead and say Show EtherChannel Summary. And let's take a look here. We've got 33, so I want 1, 2, 3, 4. Everybody else is going to be shut down. So we're going to go into global config, interface range FA1037 to 48 shut. So I'm only going to leave 4 links up, 33, 34, 35, and 36. 33, 34, 35, and 36. So now we're going to have a 4-link ether channel bundle, which requires us to investigate the last 2 bits. Since we're doing Show EtherChannel load balance, since we're doing source destination IP, we have 2 values. We have to do the exclusive OR, right? All right, so let's go ahead and say Show EtherChannel Summary. Let's make sure that we are down to 4 links that are in the bundle. It looks good there. If I were to say Show EtherChannel 1 port channel, what does that look like? And trying to get down to the bottom here, it's got all these additional links in here. I apologize. So it's actually showing me every single link, even though the links are shut down. Oh, you know what? I missed the 1. I apologize. That's why we're getting all of this. Okay, so it's Show EtherChannel. Actually, I did put the 1 in there. Port. I did port. We want port channel. That's what I missed. I knew there was a typo in there somewhere. All right, so here we go. Again, 3750, 2960, 3560. It doesn't give me the index. It doesn't give me the load. So let's do this as a last example here. Let's see if you can answer these questions while we work through this. So let's get the pin up here. So over here on the right, we're doing source and destination IP. So we know we've got to do an exclusive OR. And we know that because we have 4 links in the ether channel, 2 to the 2 is enough. So 2 bits, or 2 bits, however you want to look at it, but actually not however you want to look at it. That represents the bits. So 2 to the 2 equals 4. We need to use that. If we had 3 links, we would have to use this because 2 to the 1, when we only look at the last bit, is 2. And that won't cover 3 links, right? But that will. So we've got 4 links, so we got to look at an exclusive OR of the last 2 bits. So the last 2 bits, there's only 4 combinations. I can have 0, 0. I can have 0, 1. I can have 1 0, and I can have 1 1. Now, this should be pretty straightforward, because if these are the last two bits in an IP, this would mean that the IP would be even, an even IP. This would mean that one would be even, one would be odd. Same thing here, one would be even, one would be odd. And then this would be they're both odd, right? So this could be even or odd, and this one here could be even or odd, right? All right, so let's go ahead and run the test command. And again, we're gonna stage the IP so that it gives us what we're looking for, and then we can figure out is 33, 34, 35, and 36, where do those fall in terms of these hashes here, these results that we're looking for here. So let's get the pen back. So let's recall that, what do we got here? Test EtherChannel, test EtherChannel load balance, interface P01, IP. So again, source IP. So let's do this. For zeros at the end, I'll make one IP 128. So we'll say 10.1.1.192. Whoops, sorry. 192. And that would mean that the last two bits are definitely going to be 0, because the first two bits would be on, right? The 128 and the 64. So then I'm going to say 10.1.1. And let's pick the first, or the high order first bit, 128. Now that guarantees that the last bit in binary for the last octet, the last two bits will be 0, 0. Because again, 192 in binary is 1, 1, and 6 zeros. 128 in binary is 1 and 7 zeros. So we're good with this right here. So let's see, where does that hash? And if I would have had to have guessed, I would have said 33, honestly, because it was the 0, 0. I think it would have grabbed the first link. So let's annotate that here. Let's get that written down. So here we go, the even. So 0, 0 is FA 1, 0, 33. All right, so now we come down to the remainder, the remaining three. So now we've got 0 and 1. So the source IP, we'll stick with 190. Oops, sorry, let me switch out here to the cursor. So the source IP will stick with 192. How would I get a 1 in the last, one of the last two bits of the IP address? And give me 1 second here, because I think I want to make sure I'm representing this properly. 0001. Yeah. So how would I have the last two bits work out to 01? Well, to get the last two bits to be 01, I'm going to have to end with 0, 0 or 1, 1 for this is the second bit, and then the first bit to get the 1 would have to be 1, 0 or 0, 1 as it works out, right? So, and that's what we would have to have here. So let's go with, and that would have been the first bit. So the last two bits here, we're going to end them the same. So we will end them so that it ends up, actually, I'm sorry, that would be, that's the second bit, correct? And then the first bit would have to be one of those two. So what we could do is say, with everything is zeros in the last two, we get the zeros, but now we need the 0 in the second bit and a 1 in the first bit. So we'll do zeros in the second bit, and then it can be a 0 and a 1. So to get that, I'm going to need, give me a second here. I'm trying. This binary is driving me crazy here at the end. So we'll do the last 4 bits, and I'll work this out. So we'll say 0, 0, 0, 1, and that'll be one IP. And then the other IP would be 0, 0, 0, 0. All right, so we would do, what, 16? And then 17 would work. So I'm going to use .16 and .17 as my addresses. I believe that that is going to yield what I'm looking for. So .17 and .16. and that jumps to 35, right? Because that would have hashed out to the last 2 bits being 0, 1. Do you see that? So that would have given us 0, 1. Now this would go to FA 1, 0, 35. All right, now I'm just going to flip the addresses around the opposite way. So now what we're going to do is we're going to say that this would be 16 and this would be 17. Right? So the source is 17, the destination is 16, and what that should result in is we should end up with 0, 0, 0, 0 for the source, and the destination will be 0, 0, 0, 1. And, whoops, sorry, I left out a 0 there. That's going to exclusive OR to 0. And actually, yeah, so 16, 17 is not going to work. I'm going to need 0, 0, 0, 1. So I'm going to want 0, 0 at the end, and I want the 1 here. So this will be, the source will be 128. And then again, I'm looking at that second bit right there to be on with a value of 2. So we'll make it 128 and 130. And that should meet the criteria here for 1, 0. So let's change that. Let me say 128, and that gives us that 0 and that 0, 0 at the end. And then here, 130. Because again, 130 in binary, we're going to have that bit on. So it'd be 0, 1 will hash to 1, and then 0, 0 hashes to 0. So theoretically, we should get another interface. It dumps us back to 33, and so that is not what I would have anticipated. So we'll come back to that one. Let me take a look here at this last one, to where the last 2 bits hash to 1 and 1. Or I'm sorry, did I? Oh, you know what? I think I improperly, no, 0, 0 is 0. And now I'm drawing a blank. I'm having a too much binary. This is what happens when you play with binary too much. So again, 0, 0 should be 0. And 0, yeah, 0, 0 is 0. And 0, 1 should be 1. So that should have been 1, 0. But it still said that it wanted to go to 33. So we'll put that in parentheses here for some reason. So now let's rig it so that it's 1, 1. So it hashes to 1, 1. So to hash to 1, 1 in the last 2 bits, right, the 2 and the 1 would need to be on. And then it would be 0 and 0. So for this IP, it ends in 3. So we'll say 128 plus 3 is 131 is going to be this IP. And then this IP will just simply be 128. And that would hash to 1, 1, which should hash to a unique link. All right, so let's pull this back up and let's say 131 and 128. And it gives us 34 exactly. That's what we were looking for. And so we're going to come back. We're going to deal with this last one here. So this would have been FA 1034, right? So the only one we're missing here is 33, 34, 35. So we're missing 36. So this should be, it should hash to 36. So let me make sure that let me do another one here. So for it to hash to 10, right? So we'll work our way, we'll back into it. This would be 0, 0 to give us the 0. And this could be 1, 0, or it could be 0, 1, right? So we'll do it both ways and see if we can get it to work. So if the last 2 bits are like this, if the IP is 130, that would be, these is the last 2 bits for binary. And here, if it was 128, it would be 0, 0. So let's try that again. I already tried 128 and 130, and it showed 33. Let me flip the order of those to make sure that that wasn't my issue. So we're going to go 130, and 128, and we're hoping, no, we still end up with 33, even though that would hash out to 10. So, and it's probably something I'm doing here, but again, as you can see, we were able to figure 3 of the 4 out, so if something did hash to 10, it should hit FA1036. And so let me do show EtherChannel 1 port channel. And I typed port again, didn't I? Yeah, port channel. Okay, there we go. So this was the only one that we were missing out of the group, but it should have hashed with the 10. Let me pick a different set of IP addresses here, and we'll do one last hurrah here to see if we can get this to work. So 192 plus 2 would be 194. So that would be my 10 in the last 2 bits. And then 128, we'll change this to 32. And that would be 00 in the last 2 bits. So that would hash to 10. All right, there we go. We got it. So I don't know what it was with 128 and 130. Maybe it was because I put it in there wrong initially. But again, I hate when stuff like that happens. But all part of the learning process. So there you go. That is what we have. So we know right now that this index would be 00 for 33. 34 would be, well, the index is 0, 1, 2, 3, right? So, so the first one, going by what we have here, this would be index, and I guess we'll keep it. We'll say 0. 34 would have been index 3, because again, I'm saying that this is 1, 2, I'm sorry, so 0, 1, 2, 3. So that would have been 3. 35 would have been 1, and that would have been 2. All right. Well, this is how you can check all this stuff out to figure out how are things going to hash when they hit an 8-port Ether channel, a 4-port Ether channel, or a 2-port Ether channel. All right. Well, this has been kind of a tour de force here as an errata supplement for EtherChannel, but this is all very, very important and good stuff. So real quickly to summarize, spanning tree port cost. As you add links to your bundle, that port cost is going to drop. And here's what it drops to. With one link, fast Ethernet that is, with one it's 19. When we add a second one in, it goes to 12, a third to 9, the fourth is 8, 7, 6, it goes to 5, and then 5. And again, it stays at 5 because it's 800 megabits per second with 8 links. We don't want that to be seen as equivalent to a 1 gig link, which currently has a spanning tree port cost of 4. We then talked about the LACP System Priority. Remember, the switch that has the lower system priority for LACP, that is the switch. The default is 32.768, and the same for the port LACP port priorities. But the system priority, this is the switch that will dictate which links get brought on. And then the second part of that equation is the port priority. Ports with lower port priorities will be preferred over ports that have the default port priority, which is 32.768. And that goes for original selection as well as hot standby selection. And we saw that you can have 16 links, 8 live, 8 hot standby in an LACP Ether channel. And then finally, we wrapped up here with this, where we worked through each of the indexes for a 4-port Ether channel using the test EtherChannel LoadBalance command to figure out which hashes, right, which resulting hashes will go over which of the 4 links in the Ether channel. And keep in mind, lower end switches, we're not going to get the number of bits, we're not going to get a lot of that valuable output because they're simply lower end switches that just are not implemented with the horsepower to keep track of all that information. 6500 series, 4500 series, you are going to see it. All right, so that wraps up this supplement. I really thank you guys for hanging with me and watching this. I will see you all tomorrow evening and enjoy what is left of the Super Bowl. All right, have a great night.